Okay. Time to continue on my refresh streak. Okay. Medium. Longest palindrome concatenating two-letter words. Two-letter words, okay. You're given a string of words. Each element consists of two lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. Return the length of the palindrome that you can create. If it's impossible, create any palindrome, return 0. Okay. So CL or LC, CL, and GG. So you can do LC, CL, CL, LC, and then you can do GG. So that's going to be 3. And then you can do GG inserted between those first two. So that's going to be 4, 5. And what other one am I missing? So this thing by itself, 1. These things, 2. These things reverse, 3. This thing inserted between those two is 4, 5. Oh, it's the length, it's not the number. Okay. Okay. And here it's 8, and you can get all of them. Sure. And here it's 2 because you can only get. Okay, so what is the. This seems more mathy. Like you definitely don't want to create every single combination of words. So this seems like, what is the logic behind finding the longest palindrome? So if you have something that's the same, that could be the middle. Are these all unique? It doesn't, yeah, it's not unique. So if it's the same, it's a duplicate and there's multiple of them, then you can definitely make those together and put them in the middle. You can also put them on opposite sides. Probably better to put them on opposite sides. So for each letter, okay, so if you have the same thing backwards, then they can be put on opposite sides. Can be something funky where they're like not the same thing backwards, but you can just try to pair them up on opposite sides. So for instance, if you have the middle is going to be always even. So yeah, it's strictly, it needs to be opposite. So if it's not the same letters, in order for it to pair, it needs to have the opposite, kind of the backwards version of it. There's no other way that would work. There's no other way that you can insert it. So I'll say here, if non, I guess, what's the term here? If different letters paired, like as in AB, must have a reverse pairing in order to be part of longest palindrome. So reverse pairing being BA. So I can do a count of the number of times you see the pairing and its reverse, and the minimum of those counts times 2, or whatever however you want to think about it. If there's like an LC, CL, another CL, then only one CL gets paired. And then if it's the same, then you can put any of the same. Actually, it's the same. can't put as many as the same as you want. Okay, I think you remove the reverse pairings. You remove even numbers of like technically this can be considered reverse, so you even number them. It's like there's 2 GGs, then it doesn't need to be anything, and then you can get one final middle set that is a duplicate. Okay, so I think I have an idea. So if I were to, do I need to sort this? I wonder if it's, I guess you don't need to sort. Do you need to sort? Okay, so let's just say let's say I need a counter. So let's say counts of these pairings for each pair in counts. I'm trying to think of a way to do this so that I don't have to, so that I don't do both sides of the doubling. So could I do something where, okay, actually let's say for each pair in counts, can I actually say AB in counts, where AB is the first and second letter of that? Print print AB. I don't know if this works. Okay, it does work. Okay, so the keys, the counter dictionary is the words itself, which is a string, which is like an array of characters, and I can use this as the first and second letter of the. Okay, so let's do the simple case where it's actually the same. If A equals B, then let's say the frequency equals counts of, actually, how do I go through the, is it enumerate? Enumerate Python. Adds a counter to, returns an iterable. So, no, I don't want the index. I think it's items. Items Python. Items returns the object of values. Dictionary items. Actually, let's say k in counts.items. Print out the items. I really need to be better at these finer points of counter stuff. Okay, so an item is a tuple that is the key and value dictionary, key and value pair. So I don't know if this would work. Like A, B, C, no. It has to be something like a key or like word frequency, and I say like A, B equals word. I don't know if it's any better. Let's go ahead and just make sure that works. I wonder if I could make this into, can I make this into AB? Like that? I don't know if that works. Huh, that does work. No, it doesn't. No, it does work. But yeah. Okay, so I guess that's how I'm going to do it. So if A equals B, then if the frequency is even, then I know that I can add all this to my answer. Like that could be all the, anytime I have a duplicate letter as a pair, then and there's a even number, then they can be on opposite sides. So answer plus equals 2 times this frequency, so the number of times it is. Else, I can only do this once. If it's odd, if it's not, oops, it's gonna be, if the frequency is odd, then odd same is gonna be set to true. And eventually I'll say if odd same is set to true, then answer can be added one more time with the pair. And if the value is not the same, then I can say if, well, if these are two different values, then if the opposite is in the word, or is the word that counts. Do I need to actually concatenate and create a string here? I need to concatenate and create a string. Don't really want to do concatenation. But I don't see a way out of it. So I wonder if I can do. I wonder if I say if I can do something like if counts has, if BA is in count. Let's say return 10. Let's see if this works at all. Yeah, so I think I need to be actually so A and B are characters. I don't know if I can concatenate characters like this. I'm just blanking out. Okay, I can't concatenate characters like that. Okay, so if BA is in count, so that's the reverse of it. Then BA is in counts, then I want to take the, what do I want to do with it? I either want to not do it later on. Ooh, can I remove stuff from accounts? Remove key from counter. Can I do that? To remove a key from then I'm iterating over the items, and I don't think I can do that when I'm over iterating the items. It's just it makes it incorrect. Not safe. So I could possibly do something where I have a set of things that I've looked at already, so I can skip that later on. Or I can set the frequency of that one later on to 0. If BA is in counts, then I want to BAs and counts, then the lower of the two is the value that I want. So lower is the min of the counts of this frequency and the counts of B plus A. And then the answer is increased by 2 times the lower pair. No, it's 2 times the lower pair. So if this thing has 3 and the other one has 5, I think it's 4 times the lower pair, like, because it counts both. So each time you pair it up, it's 4 characters that it's accounted for. And maybe I can do counts of B plus A is equal to 0, so that when it goes across that one, it doesn't increase it again. Okay, let's try that. Wrong. Oh, return answer. Okay. Wrong answer. Okay, so what do we have here? So my result for this was 2. It should be 22. Huh, really? Oh, whoops. Okay, so if it's an odd number, then it's actually the even amount that needs to be, the smaller even amount needs to be increased. So answer plus equals 2 times the frequency minus 1. Whoopsie. I messed that logic up, or forgot to include that logic there. Okay. Okay, there, it still could be faster. Let's go ahead and think about this. I think counts, getting the counter of the words is fine. I wonder though. I wonder. Could I do this in maybe one pass without counter? So what would that look like? That would look like as I create the dictionary of frequency, basically, then I do the logic for each thing immediately. I do the logic for each thing immediately. Okay, let's try to improve this using it one pass without creating counter. Counter is really fast in my experience, or in my coding on this thing, so that I generally hesitate to actually use substitutes for it. But so let's go with for every AB in words. I do need a dictionary, a default dictionary, I think. So let's say frequencies is equal to a default dictionary of ints. And if it's the same letter, then well, oh gosh. Actually, let's say word. Yeah. because I don't want to recreate it later on. And maybe that's actually what's at issue here. I need to, I guess I never add EA. Okay. Well, if word of A is equal to word of, or word of 0 equals word of 1, I'm dealing with the same letter. Then, okay, so actually when I say frequencies of this word increased by 1, and it's the same letter, then if I look at the new frequency and that frequency is even, then I can, so let's say there's going to be an odd same count. So there's a number of words that I come across that are the same letter, or I guess it's not odd. Yeah, it's the same letter, but there's an odd number of them, so not an even number of the same. So like if it's CC, that counts as odd same. Then if it's another CC, then it counts as an even same. The number of times I see the same letter, but that's odd numbered. Whatever. So here, if it's the same letter, if the frequency of this word is currently even, then odd same is going to be deduced. Actually, so let's go with the logic of if it's an odd. So like the first time I see it, so this is the number or count of words with same letter and odd frequency so far as I pass through all the words. So if it's an odd number, then you can't really combine it, or you can't really add it to the answer immediately, because you don't want to add multiple one of those. But if it's an even amount of the same things, then you can. So if it's an even amount, then the odd same is going to be deducted by 1, and all 4 of those things can be added. Otherwise, if it's not the same letter, then I can say if let's go ahead and grade it backwards. Backwards is going to be BA, or words of 0 plus words. I don't know if this is faster than doing the other way of doing this, is like word bracket colon -1. No, I don't know. Well, I can double check it. So if the backwards is also, how do I want to do this? If the frequency of backwards equals 0 is greater than 0, I think this should be continuous. I shouldn't be doing this if this is the same. The frequency of backwards is greater than 0. What I think I can do is I can remove one of each. So, because I can then make it a pair. and frequencies of, maybe I should be doing this first. Maybe I should be doing this first. Okay, so I'll worry about it later. Frequency of backwards is removed by 1. Frequency of this thing is removed by 1. And I add 4 to the answer. So I pair them up. And if there's 0 bit, then it doesn't get paired. And then return the answer. Oh no, I need to fix the odd same deal. So if there is, if odd same is greater than 1, greater than 0, then the answer can be incremented by final 2. Same deal with here. Seems okay, not correct at all. Huh. So the first time it does LC, next time it does CL, should increment the answer by 4 there. So let's say print word and backwards. Huh. CLC. Words at 1 plus words at 0. How did it get to CLC rather than just CL? Backwards is word bracket 1. Oh, whoops. Word versus words. Okay. Okay, let's see if that works. Oh my lord. Holy bejeebus. That's so much worse. Okay. Okay, so this is definitely not working correct, or not anywhere faster than previously, so maybe I need to just modify this counter thing. I mean, the other thing is I increment the frequency of words. Maybe I need to know the frequency, because I can come across a bunch of like CL, 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 and then come across with the LCL, CLC. So it can't be just like a set, I see in the backwards version of it. Creating this thing is kind of mid. Don't like creating strings. Maybe it feels slow. Feels pretty darn slow to create a string. Then if I didn't create the string, what would I do? Okay, so I think maybe let's go back to the other version and think about how to improve this one maybe. counts is the count of words. Answer 0, odd same as false. Every word and frequency. I think maybe I can just say this is for every word and frequency. If the word at 0 equals the word at 1, then do that. With the frequency, I wonder if I could do something like, can I make it this not into an if statement? So I could say odd same is could maybe say answer plus equals to, let's say the remainder is equal to frequency mod 2, and I can do answer plus equals 2 times the frequency minus the remainder. So that works there, and then I need to do something where the odd same is. And the odd same could be incremented by this remainder. And then this thing is just initially 0, and if it's greater than 0 here, then increment. So okay, I got rid of one if statement. I guess I can also get rid of the remainder calculation here, or the remainder variable, and say this is frequency mod 2, and then this is frequency mod 2. Okay, I got rid of an if statement there. And then if the reverse is in counts, if the reverse is in counts, I could do if the reverse is in counts and also A is less than B, because only if it's in order, then that's how it determines when it needs to figure it out, when that's been done or not. Okay, yeah. B plus A is in. Actually, let's do this one first, since this one might take more processing. So if A is in B, and if it's not, then don't try process at all. Then you get the lower of the frequency. Okay, and then you have to reset to 0. Oh, okay, this needs to be word 0. It's less than word 1. And if you add word 1 and word 0, then get the counts of word 1 plus word 0. Okay, so how much did I improve there? It was 54 milliseconds on the first pass, the first solution, and then this last one, it was 47. Still not quite fast enough. If they're the same letter, for word, comma, frequency counts. I mean, I wonder if it's actually better if I just see for every word in counts, frequency equals counts that word. Is that any faster than using in items? Index at a range. Oh, whoops. Word frequency. Every word in counts. Well, that was considerably faster. I wonder if my other optimizations weren't strictly necessary then. Like, I would really prefer, because the logic here is nasty, I would really prefer to say, like, the backwards version of the word is word at 1 plus word at 0, if I can afford that in terms of speed. It does make this code a lot more readable. Okay. Okay, so same speed there. Let me try one other thing, and this is the other thing I was thinking about. Like, can I do just word colon colon -1? How fast is that compared? Slightly slower. Interesting. Interesting. So, well, it's like 37 milliseconds versus 40 milliseconds, which is like 10%. This is all random, I guess. Okay. Alright, I think this is how I want. I guess using dot items is just slow compared to iterating through the keys and just creating the value from looking at the thing. Okay. So yeah, the one I always find it interesting to be able to change if statements to raw non-if statements. Actually, so let's go ahead and go back to that one, the first version of this. So it's like first version was with an if statement right there. Where is my initial? Okay, so this thing, this if else. So this is the non-if statement version of it, and this is the if statement version of it, where odd same is a boolean. And let's see if this was actually necessary or a speed up at all. So in the lab, checking. So there was a minor speed up there. Although I'm going to do one more run to see if that was just random variation. All random, almost kind of slower. And then if I did, this thing is actually an integer. And this thing are these two statements, but I thought the if statement odd same is greater than 0. Whoops, colon. Alright, I guess it's all kind of random. I don't know if it's anything faster. But it is interesting to be able to sometimes, especially for if statements that deal with even or oddness, there's like I feel like there's almost always a way to create an equivalent statement of calculation where it kind of removes the if statement and does just some operation on like the odd bit to do what you're trying to do. So yeah, there's no if statements here. In any case, so what did I do? So for summary, so it can be boiled down to three things. So same same letter pairing, like AA, all even kind of numbers of them, even counts of them can be in Palindrome. So like if 5, then 4 will always be good. So if there's like 5 AAs, you can always do 4 AAs. The last AA, so for same letter pairing, if odd number of same letter pairing, only one kind of odd one, only one final pairing will can be used as middle palindrome. So for instance, if it's like there's an AA, there's a BB, and a BB. So technically you can use 2 BBs and 1 of AA or BB. So the middle can either be AA or BB, but it can't be both. So because the A has an odd number of occurrences and the BB has an odd number of occurrences. And then if not same letter pairing, then must have matching, reverse or backwards version, and contribution from that is based on the lower count. So if you have CL and LC and you have more CLs and LCs, then the lower of the two frequencies would work, and then you do 4 times that for the number of letters that are contributed. So summary is just going to be this determine what type of pairing it is, same versus different, and I just you just do word at 0 versus word at 1, and apply logic on the frequencies involved. So if it's the same letter, then if it's an even number, or whatever the frequency is, whether it's odd or even, I would subtract the remainder of it by 1, or remainder of it divided by 2 to make it an even number. This is guaranteed to be even. This is frequency made into lower even number, and then contribute that to the answer. And if it's an odd frequency, then I'm just going to add this as a possible odd same, the count of the odd same. Count of pair of words, of same letter words that have odd frequency. and then otherwise you do the backwards version of it and check to see the backwards version here, because you want to because you only want to do this once for the version and the backwards version of it, then then you can check the letters are alphabetical or not. It's possible that you do, yeah, it's better if you do this. You also do it so that your code actually works for both the backwards version and the forward version, and kind of does a duplication and then subtraction maybe. Yeah, it's just more logic, or more convoluted logic. Time complexity, this is going to be O of n to create the counter frequencies, and also to do a pass through all the words in the array. Yeah, I mean, the number of unique words could be on the order of n. And then space complexity, this is O of n for the counter data structure. Cool beans, cool beans.